Good morning. Today we want to see a problem in kinematics. Drops of water droplets are fall from the roof of a building of height 16 meters at a regular interval of the time. When the first drop strikes the ground, at the same instant, fifth drop starts its fall. Find the distance between the individual drops in the air when the instant first drop reaches the ground. Before getting into the problem, we must have a clear understanding about the problem statement. It is given that the building is of a height of 16 meters. Water droplets are falling from the top of the building. When the first drop starts its fall, it takes certain time to reach the ground. Let us consider it as a T1. So to reach the 16-meter height, that is from top of the building, to reach the 16 meter, that is height of the building is 16 meter. To reach the ground, it takes time T. Likewise, continuous droplets of fall, and we have to calculate the distance between the each droplets, and the time taken between the each droplets are uniform. And it is also given that when the first droplets fall, the starts falling, and when it reaches the ground, the fifth droplet is about to start from the top of the roof. Let's get into the problem. Height of the building is 16 meters. The drop of rainwater falls in regular interval of time. These are the two given data from the question we'll be able to understand. We are having a standard formula to find the height. H is equal to ut plus of gt square. H is the height and u is the initial velocity and t is the time taken and g is the gravitational force. Since it is falling vertically downwards, we have to take the g value as 9.81 meter per second square. As already said, we have to consider the time t for h1 16 meter. We have to take it as t1. We are substituting the known value. That is, we know the value 16 and the initial velocity is 0. And we don't know the time taken t1, it will be t1 and half into 9.81 t1 square. By solving this, we'll get the t1 as 1.8 seconds. In the given data, it is clearly stated that the time interval between the each droplets is uniform. So we have to divide that by 4. The time t1 we have to divide it by 4. So 1.8 divided by 4. So each droplets have a duration as 0.45 seconds. So when the first droplet strikes the ground, the second droplet travels 1.35 seconds. And where likewise the third droplet T3 travels 0.9 seconds and the fourth droplet travels 0.45 seconds. To find the motion of height of the second drop, we have to substitute the T2 value in the same equation. H2 is equal to UT2 plus half GT2 square. Therefore, H2 is equal to 8.94 meter. Likewise, for identifying the H3 value, H3 is equal to UT3 plus half GT3 square. By substituting the T value in the same equation, we'll get the H3 as 3.97 meters. And to identify the height of the fourth droplet, we have to substitute the T4 value in the equation. H4 is equal to initial velocity for this drop also will be 0. So 0 T4 plus half into 9.81, 0.45 square. We'll get the H4 as 0.99 meter. Now we have calculated the height of each droplets. They were asked to find the distance between each droplets. To find the distance between the individual droplet, the distance between first and second droplet, H1 minus H2. Likewise, to find the distance between each droplets, we have to subtract it from the droplets, subsequent droplets. Second droplet minus third droplet, third and fourth and fifth. H1 minus H2 is equal to 7.06 meter. H2 minus H3 is equal to 4.97 meter. H3 minus H4 is equal to 2.98 meter. H4 minus H5 is equal to 0.99 meter. Now, this is a small question which is given for your better understanding, and you have to answer this question. A race car starting from rest moves along a straight track with an acceleration as shown in the graph, where for t is less than or equal to 10 seconds, the acceleration is 8 meter per second square. Determine t for the car to reach the speed of 50 meter per second. Here, it starts from the rest and moves to a straight track. For that, the acceleration need to be given. And when it reaches the maximum speed, it travels in the same uniform speed. So we have to find the t for the car to reach the maximum speed of 50 meter per second. Thank you.